Hi guys. Alright, we're back. Hopefully I can speak better now. I'm feeling a lot better. So, uh, anyway, I went ahead and tore into the Airline 62 105 or 103, both same chassis. And I thought I'd show you where I'm at. There's a decent amount of rust on top, so on the chassis, so I decided to strip it down and prime it up and paint it. So this is what we got right here. It's still got some signs of pitting, but it's not too bad. So anyway, I got a few other things to do yet. The top on the transformer was a little rusty and stuff, so I went ahead and cleaned her up, and it's basically about ready for priming it. Rest transformer seems to be fine. So anyway, I want to show you some interesting things I did find. First of all, the little 12 microfarad 25 volt cap that was in the radio. I pulled the insides out. It's a very early dry electrolytic, and this is what you have inside these, the old style ones. They use basically kind of like a cheesecloth instead of a paper, and then they would basically embed the electrolyte into here. It was kind of like similar to a paste, or a little bit thinner, but not much thinner. And then they just soak it up in here and get it in there, and then put the plates on each side. Of course, remember, electrolyte is one plate actually, and then an anodized or oxide aluminum is the other plate, which happened to be this one here. It had dried out, and these openings here is where it was trying to short out at some point. So anyway, more modern, well, even relative to this radio, they went to a paper and a little bit much wetter electrolyte. Still considered dry, but they'd soak the paper in it and soak it up in there. But this stuff here, these usually dried out fairly quickly, relatively. So, and remember, it had a replacement that was put in there, and I don't have it on the bench, but they'd put a replacement in there probably 10-15 years later. So anyway, that was in the cardboard box. Basically all it is just a cardboard box and then sealed shut with wax. So that'll be easy to stuff. The line filter cap is in a metal can, so the little rectangular safety cap that we'll be putting in here easily fits inside here and will be easily hidden away. I went ahead and unstuffed a lot of the caps, all the caps. Most of them were crimped over on the ends and then waxed, where they would have these little discs on each end, and then that was all waxed in, and the cap inside was fully waxed in place. Now all the parts on this that were original, like here's the original electrolytic, had orange paint on them. And so when I was looking at this cap, which this is the tone control cap, which is unlike the rest of them, there's no values, nothing on it, and it's not burnt. It's just black, painted black, with no numbering whatsoever. But there was wax on the outside, and when I started, when I first got it out of the circuit and everything, and was going to unstuff it, I noticed that I think it was on this end, there was a little bit of orange paint on it. So that told me that it actually had to be a factory original. Of course, once you take the wax off, all these had orange paint on them. But once you start heating them up to take them apart, there's one that's still got the end in it, right there. You know, the paint's on top of the wax, so it comes off. These micas test real good. Test exactly what they're supposed to be. But here's another sign of the orange paint, telling you that this was put in at the factory. Oh, one thing about, you notice we got what some people would refer to as coax here. When you see this in a radio, this is shielded wiring. It's not coax. There's a big drastic difference between coax and shielded wiring. Coax is designed with a certain amount of capacitance between the outer conductor, or what would be considered the shield, and the center conductor. In fact, the insulation around that center conductor is got a dielectric constant to it that is kept at a particular value throughout the entire coax. So that what that does is give you a certain amount of impedance on the line and stuff. Where you got something like this, this is they just take a braided shield and put over it. In fact, here is just 2 wires, and then the shield. This is just for bringing audio up to the volume control and then taking it back to the grid of the first audio tube. And they felt that they needed to shield it to keep noise out. But that's a shielded wire, it's not coax. Some radios, like Zenith, they liked using what appeared to be basically look like a spring. And I've got one. I got a new Zenith I'll be doing another video on. I just got console radio, and I'll show that to you. It's got some of that in it when I get to that. So anyway, there's that burned up capacitor. There's nothing left of the tube. In fact, you can see right here probably where the paper ends being rolled around, the paper and wax. These have 2 end caps on them because these are actually oil filled, oil filled caps, and they put the 2 end caps in there at the end of the tube to seal it up and stuff. And then I don't know if you can see it very well here. This did have an insulation on it, probably like a spaghetti or something, that went up here to keep it from. This side went to ground. This side went to the other tube. So when she shorted out and everything, it heated even the wire hot enough to burn that insulation. Pretty much gone. Okay, let's see where we're at. Oh, when all it's inside this cap here, basically just a standard wet electrolytic. You just there's your anode, and then the electrolyte's just a liquid, and then this is your make the connection to that electrolyte, because electrolyte's always the negative. And I left the insulation still in there when I stuffed it. All I did was, you can't solder it aluminum, but this end is crimped onto here. That is the solder lug. I uncrimped it, and then basically all I did was took some number 12 electrical wire, insulated, and I cut a short piece off, or something like this, stripped one end, crimped the piece back on and soldered it, and stripped some off the other end and connect a wire onto it and connect it to the positive on the new electrolytic going in there. And then I wrapped around, even though this insulation is good, 600 volts, it's pretty sloppy in there, so I put a couple layers of heat shrink tubing on there, and then kind of reamed out the old rubber, stuck it in where it's kind of halfway tight, and then just hit it with some black hot glue to hold it in place. Now this electrolytic was kind of interesting, the factory one that was in there. Basically on these, they're not clamped into place, they're held in place by the threads, so you can't really cut this end off to open them up, because then there's nothing to hold it back on. But they do have a crimped top on them that looks kind of like this, and you take a sharp utility knife and just put it right in there and rock it back and forth. Couple 3 rock. If you've got a new blade in, about 2, 3, 4 or so rocks, and it generally will just go right through. And then just move it along. Just keep moving along until you get it cut off. Well, I did that, and of course the top of it was dirty like this, except it was just absolutely plastered with dirt. And I didn't think anything more about it. This is aluminum can. Now they made some of the very early ones, they made out of copper. Couple, 3 companies actually made some. They had copper cans, but it didn't take long. Copper is kind of more of an expensive commodity than aluminum, so they started making them out of aluminum. And generally you just got aluminum top on that's crimped on, and aluminum body. Well, when I took this one off, first thing I noticed was it was green. Now why is it green? That's what I asked myself. It shouldn't be. What that is the reaction between the electrolyte and the metal. Well, aluminum, it should be white, not green. Well, it turns out that it had a copper top on it that they'd crimped to the aluminum can. That's the first time I ever seen one where we had a mixture of 2 metals where we had. So that's basically what it was, which is a little different for me. I've seen all copper and of course all aluminum. In fact, I forget now who it was. It might have been Airvox there for a year or 2 around 1930 or 31. Actually made a couple steel ones. But I do remember some steel ones that were made. But that's the first time I ever seen one where they had aluminum can and then they put a copper top on it. So anyway, I got to this is the volume control, and it's pretty obvious that it's been replaced. Looking at the shaft, it's kind of a semi-universal shaft. Been pinched off here, so it's probably a little bit longer. And then they kind of ground it down there to make fit. Okay, but it's a old Maori and period, pretty close to the same period. It's from the 30s, so it's fine, and it's good. So when I got to the tone control, I've still got to clean the shaft up, but I noticed it looked like it was kind of like been cut off. There's like a cut right through here and then a slash off here. I thought, okay, it's been replaced too. Until I got to the tuning condenser. This is a shaft that goes to the tuning condenser. The tuning condenser is geared down, so it's got it don't go directly to the rotor plates. They run this off to, this is mounted on towards the side, but it is actually cut an exact same way. Now I know this is factory. The tuning condenser's part number on there, plus it had some orange paint on it. So this is how Airline, or whoever made it for Airline, they would cut these off. They were probably longer and they'd cut them to fit. So I thought it was kind of interesting. But the rest of this has been a replacement that I made. I actually had to, the old one was shot, and I'll show you here in a minute. And I had another one that was about the right value, just a little bit lower in value. And it was good, but the shaft was a lot shorter. So I ended up taking that shaft off the part that, your wiper part in here, and putting this one on. I had to solder it in place so it would stay because they were crimped. And so I got the original shaft, but a different unit. It's got some holes in the back because it's supposed to have a switch on there. What was inside the old one was an ordeal like this. You had the carbon around the outside. This is your rotor, and it would push against this here, and that would push this up against the carbon, and then that fed out through the center wiper connector on the outside. This is what they, it was in a Bakelite box like this. This is where the carbon makes contact with the two ends. And the interesting thing about it, this thing sits down in here, something like this. It's kind of bent a little bit. But if you notice here, there's a little round piece here, or kind of cut out piece. Well, that's to keep it from, when you're moving it around, you're turning the shaft to keep it from moving around. It keeps it steady, but it's moving around like this. The reason is down inside there is a broken part in there off this Bakelite. I don't know if you can see it, but you can kind of see where it looks like it should have been right in there. Kind of dull. Well, this was what was in there. That's it right there. So I don't know if it froze or something and they turned it real hard and it busted that off or what. But anyway, what I found inside was this. This is your carbon. It's just a piece of paper with carbon on it. You can see where it's burnt right through, right there. And this other piece is right here to make up the rest of it, and most of it was gone right in that one area. So my guess is that tone control cap probably, when I tested it, it was almost, it was leaky at the lowest voltage. It basically, when I went to leak test at almost 0 volts, it was leaky. So, and when I checked with the ohm meter, it showed signs of very low resistance. So this comes through that goes to ground, and between ground and the plate voltage on the output tube. It's just that capacitor and this little half watt or quarter watt potentiometer. See, this is not a heavy duty thing. This is your main resistance right here, which is on a very thin paper and stuff, so it wouldn't take much heat. So anyway, it burned. Okay, batteries just went dead in the camera, so I had to replace them. I think I was pretty much just finishing up on this, talking about how it's got shorted out. The cap probably shorted, and this wouldn't take the power of the plate going to ground, and just burned it out. So the other things is um, got the rest of the coils pulled out and everything. This is the antenna coil here. I marked them just in unison where they go on, so I don't have to really think about it and go through figuring out exactly where they go. This wire here, which is part of that, which I told you about and showed you on in the first video about the capacitor that's made up by the gimmick coil. Well, this is that right there. It goes underneath the winding right here and comes down and hooks here. It was broke. It just came loose right in here. There's a little piece of tape that they had over it, and it just came loose. So I peeled that tape back a little bit and was able to get enough wire there, and there was enough free wire here that I was able to J-hook on both ends and get a good connection, and soldered it. And I put there's some black electrical tape underneath, and then I pushed that down, pushed this other tape down, and then I took some wax and just melted some paraffin wax, melted over this to hold it all down. So it's good now. But the antenna coil, the antenna wires I just cut off because they're rubber coated and they're going to need to be replaced. They were pretty shot. This is RF coil, the tuned RF. Everything checks okay on it. And then we have the first IF and the oscillator coil. This is your oscillator coil right here, and then on top is the first IF, which is just identical to, I haven't even pulled the one back out of the can here. It's just bolted in, but it's identical to that one. And now this one here we got to do a little surgery on, because there's a resistor right down there. So a 1 meg resistor. It hooks here and comes up and hooks here. So I need to replace that. It's a 1 meg and it's testing about 3 point something megs. So it's way out tolerance. And speaking of resistors, I'm going to mold them. I want to keep the look. I wouldn't have to mold all of them. About half of them are, they're close enough. They're no more than 25% high. But some of them are quite a bit higher. So anyway, I got two sizes. This is a 1 watt, and this is a 1/4 watt. Most of the resistors in it's 1/4 watt. Now I got the leads all straightened out, and I'll have to make up some molds and stuff. So be looking forward to that. I'll probably do a little demonstration on that. The canned ohm resistor, remember it had one at one end had been burned out or shot, and they had this guy tied across it, which is supposed well, it was too low. It's supposed to be 18K, and this is like 10,000 ohms. I don't know if you can see that. But anyway, it measures about 30K. So I took it out and I tore it apart. It's kind of beat up just a little bit, but it won't look too bad once it's in there. But basically what I did was uncrimped it. It's fairly soft metal. And then the wire wound resistor is wrapped around this stuff here, which is one solid piece all the way through. Now I cut some of these out so the new resistors would fit down in a little better. But I did keep enough of this where these hook on, so it'll hold them steady and solid. The old paper came out alright, insulating paper, but just to be on the safe side, I put some more paper around it, just basically a printer paper. You just kind of fold it up. Anyway, it's on the first paper inside is the original paper, and then it goes on the outside of it. And then I just kind of painted it black so that that white wouldn't show up so bad and be rather obvious. Anyway, it tests good. This does not drop much current. There's most of the only two resistors in here are anywhere near a half a watt, and the other two are down less than a quarter watt of actual power dissipation. So I think more or less they use the can ohm more just for convenience. Saved them putting a terminal strip in. So it should be just fine. And then I stripped down and cleaned up the variable capacitor and got it all put back together. Took all the bolts out and everything, pulled this thing completely apart. There was some kind of rust on top of here and some dirt, rust inside and some dirt inside. This thing sits up like this. So I took it all apart and bathed it in evaporust, and it's all back together, ready to go in. I just got to work out what I'm going to use. There should be rubber grommets on here, and I think I got something that will work for it as it mounts on rubber. Okay, I don't think there's much else that I can think of. Look for a future video as I start putting this thing back together. I got to finish up on some other stuff. Of course, paint the transformer can and get it all painted, and clamshell, and everything tests good. Audio transformer's fine. Everything's fine on this. And now slowly start putting other things together, and then start slowly putting the radio together. So there'll be another video coming up. I might show how to stuff one of these style. Unstuffing them is pretty simple, straightforward. Basically all you do is you uncrimp one end. Just kind of uncrimp it. It's not hard to do. Heat it up first, get some of the wax melted, and then uncrimp it, and then heat it again and pull out or push out, either way. The old cap it's in, they actually come apart pretty easy. And as far as putting them back together, if you don't already have one end in, you shove one end down to the original crimp in, and then put your new cap inside it. You may have to put something in there, some paper, cardboard, tape, whatever, around it just to get it fit a little snugly. Or you can even just shoot some hot glue in there, just kind of support it a little bit in the center, or you don't even have to do any of that otherwise. But if you don't, really, it'll kind of move around inside once you put the other end in. And you recrimp this down, and you might hit it with some a little bit of hot glue just to kind of hold it, or wood glue, or whatever you want to use. So anyway, I'll probably do one of these putting together, and we'll try to do something about a little demonstration on molding these. resistors. So that'll be coming up in the next video. And then probably be doing a little more about slowly starting to assemble the thing and following the schematic. I printed the schematic out to make it a little larger, but also mainly to get some values on here, because the schematic came with no values on it. But at least they did put on the same page actually the parts listing, and which has the values, but it's just a little nicer to have them on the schematic, and then of course the tube pin numbers and stuff, except for the 80 rectifier. It's just 1, 2, 3, 4. 1 and 4 is filament, and 2 and 3 is the plates. So anyway, I just wanted to get, instead of looking at a blank thing where it just says R15, I can see that's a 200 ohm resistor. So we'll be following it to put this thing back together. Most of the wiring in it seems to be in decent condition, and about the worst wiring in it was really the antenna lead, so that'll be replaced. So anyway, I guess I'll see you guys on the next video. If you like this video, give it a big thumbs up. I've been kind of down this week, trying to catch up on stuff, and since I've been sick and everything, I did get to answer one comment. I'll try to get in there and answer a few others, or just, if nothing else, thanks for your comments, because most of them are just you people commenting, not asking any questions. But one person did, and on a different video actually they watched of mine. So anyway, another video will be coming up. I want to kind of clarify some stuff on the capacitor video I did about ceramics and stuff. So we'll be doing just kind of an update to that. And then of course we'll be getting into, I want to do, like I said, it may be a series of videos. I'm not sure if I'll get it crammed into one video, but looking at FM detection. There's 3 primary types, so we'll be looking at those. So anyway, thanks again for watching. Thanks to my new subscribers, and thanks for your comments and your kind words and everything. I guess I'll see you guys on the next video, and look forward to another part on this one. Thanks again.